Okay, so my project is a kind of Fitbit or fitness wristband. Um, so this is actually going to go around your wrist. This is the base plate, so you can put it on your hand. I just don't have it fully enclosed because I want to show you the working parts of it. This is the top part. You can get to the reset button. You can plug it in. Um, I left these two out, the RX and TX, to the Bluetooth so that I could still reprogram it because it doesn't like uploading programs with the RX and TX connected. It gives me errors. So let me show you what's in this. You can see that it's plugged into right here an Arduino Nano. And the Arduino Nano it chooses between two power sources. If it's plugged in and it has a battery source, it'll choose the one that has most energy or the highest voltage. So in this case, that is the computer because I killed my battery from playing with it. Here's the battery right there. I did have to do a little voltage divider in order to get the RX-TX to work out because logic for the Bluetooth is 3.3 volts and it's 5 volts for the Arduino. So you can see in here there's also a vibrating motor right there by my fat finger. There is an accelerometer right here. And the Bluetooth is tucked underneath everything. So those are the working parts of this. There's also an on-off switch. And when it's running on battery power, that works. But for this, I'm going to keep it plugged in because I don't have another battery to replace it with. So the idea of this is that it uses the idea of F equals ma. So I can feed it a mass or a weight, and then it uses the acceleration from the accelerometer to say how much force caused that acceleration. So you can use this while you're lifting weights to figure out how much force you're exerting throughout a repetition, and that was the idea. So to do this in my code, I had to calibrate the accelerometer, and that was difficult. That was the most difficult part. And I calibrated it while I was using an Arduino Uno. So now it was actually pretty accurate, but now it's not right on target. It's a little bit off. Let's see. It does a loop. You can see right here it collects a bunch of samples and returns an average. And it does that very quickly. So as far as the acceleration that I'm using for calculations, it's a square root of the x, y, and z squared, so that I'm getting just a resultant, so that any direction it's moving, I know what force is holding it there, whether that be the force that the countertop is exerting on it from just gravity. So you'll see that in just a minute. So it works with my phone here because of the Bluetooth device. So it's connected right now, and I can go ahead and run what I wrote. And so I'll go ahead and send 50 pounds to it. So I'm telling it this is attached to 50 pounds. You can hear the vibration going. So right now it's telling us, that's a lot of focus. It's telling us that we're close to 50, and that is correct because it's sitting stationary. So the force exerted on it is 50 pounds. And you can see in here my numbers are actually saying that it's 61 pounds if you look to the right of the Y that's feeding through there. So it's close, but it's not perfect. And so as I move it, it'll change that acceleration as if I'm doing repetitions. And so that is just pretty much what I wanted it to do. I think if I were to actually use this more, I would change the graphical interface so that I could get more qualitative data out of it. But yeah, that is the project, and I think it turned out pretty well. So thanks.